when we have b squared minus 4ac, or the discriminant, when it's less than 0 or negative, you cannot square root the negative, so that we have no solutions, okay, for what we call imaginary roots. But basically there's no solution to that quadratic equation. When b squared minus 4ac is equal to 0, you're going plus and minus 0 from the vertex, which means that your solution must be at the vertex, or so you have one solution, or what we call two equal roots. And those are the same thing. And when b squared minus 4ac is greater than 0, we get two solutions, because we're going to go plus and minus from the vertex, and it's going to give us two real solutions along the x-axis. Okay, so we can use this discriminant then to just tell us how many solutions we have, or we can solve these types of problems of the discriminant. So here we're being asked what b value gives us an equation that's equal to 0. Well, one thing that we could test is we can just go on to, into our graphing tool and just test different b's, and all the b will do is it's a vertical shift. It'll just move the graph up and down. Why? It won't change the shape. It'll just change the y-intercept position. So we can do this physically on our graph, but we can also do this algebraically now, because we have this issue here where we can say that if it's one solution, you know that the discriminant b squared minus 4ac must be equal to 0. Okay, so that we have plus minus 0, which gives us one solution. So when I plug these in, I get 2 squared minus 4 times a times c, which we're going to use as b, just highlighting that. Okay, so that b is really our c value here. And then we can solve for and make that equal to 0, and we can just solve for b. So we get 4 plus 12b is equal to 0. So we get b is equal to negative 4 over 12, or negative 1/3. Okay, so b value of negative 1/3 will give us one solution. It will give us the vertex at the x-axis. Okay. Now we could do the same thing. We can solve for this, do the same thing here, but for 0 solutions, we're just going to make the discriminant less than 0, because if it's negative, we cannot square root the negative, and we're going to get no solutions. So again, I just plug in. Okay, so 2 minus 4 times negative 3 times b. This is essentially the same equation. We're going to end up with 4 plus 12b less than 0. So we know that, let's move the b to the other side. Okay, actually, let's do this. We'll do 12b less than negative 4. That way we're not dividing by the negative. We know that b must be less than negative 1/3. Again, if there's one solution for a parabola facing down, when the y-intercept is negative 1/3, if we drop that down, we know that the graph is going to have no solutions. Okay, so basically I have my graph for one solution, and I'm not sure where the vertex will be. It looks like the vertex is going to be somewhere over here. So if our y-intercept is at negative 1/3 here, okay, that's not negative 1/3. Okay, if it's negative 1/3 here, I get one solution. If I make it less than 1/3, it's going to have no solution. And then the converse, we can make it bigger than 1/3. Notice the vertex goes up. Now we have two solutions, two places where it crosses the x-axis. Okay, so two solutions, then it's going to be the opposite. Again, we can just plug that in, but essentially we're going to end up with greater than negative 1/3. So this time we want greater than 0, and when we solve this, okay, we're going to end up with the same equation. So we end up with b is greater than negative 1/3. So if it's more in the positive direction, we're going to get two solutions. We can see physically how that's going to happen. Okay, so this is the same thing we can do here. We can figure out the b values that will give us two solutions, one solution, zero solutions. Now, since really the boundary is the one solution where it's equal to 0, okay, where b squared minus 4ac is equal to 0, we can just solve that, and then we can change our inequality here. So b squared, again, in this case, the b value is going to be in the b position. Okay, so b squared minus 4, so I should make sure that that's clear. Okay, so b squared minus 4 times a times c is equal to 0. I get b squared plus, so this is going to be b squared plus 60 is equal to 0. Okay, so in this case here, well, looks like that's not possible. B squared cannot be equal to negative 60, so that means that this must have a solution. This is not possible. We can't actually solve for this equal to 0. So we know that if we're going to solve this, then we can say b squared is greater than, b squared plus 60 is going to be greater than 0 for two solutions. And I'm just going to box this in here. So this is for two solutions. I'll do it in red. B squared plus 60 is greater than 0. Well, b squared for plus 60 is always bigger than 0, so b is all real numbers. Okay, so any number I plug in for b is always going to be bigger than 0. Okay, so b for all real numbers of b, this will have two solutions, and it's not possible to have 0 solution or 1 solution in this case. And we can do this and show this on our graphing tools.